everyone and welcome back to Data Science and AI lecture series brought to you by PostNetwork Academy. I am Bindeshwar and today we will dive into the fascinating world of set operations and important laws. This session will give you a strong foundations in concept essential for data science, axiomatic probability, machine learning and other fields. So let's get started. So first of all, union. It means that X belongs to A or X belongs to B. It means it may be in A or it may be in B. Let us see an example. So if you take any element from A or B, so that would be in A union B. That means taking elements from A and elements from B and just make a new set, that is A union B. Next example, A is A comma B and B is B, C, D, and if you combine A union B, A, B, C and D. Here you can observe that repetition is not allowed. So you will write any element only once. Intersection means common element. That means it is in A also in B. So it is written as X such that X belongs to A and X belongs to B also. So suppose that A is 1, 2, 3 and B is 3, 4, 5. So intersection B means 3. Another one ABC, that is A set and B set B, C, D. So A intersection B would be B and C. Set operations, that is a complement, that means X belongs to U such that X does not belong to A. So here if U is universal set and A is 1 and 2, so A complement, it is denoted by A raised C, so A complement is 3, 4 and 5. Another example, universal set is A, B, C and D and A is AB, so universal complement of A would be C and D. Let us see difference. So A minus B, that is, it is in X, X belongs to A but not in B. So if A is 1, 2, 3 and B is 3, 4, 5, so A minus B would be 1 and 2. The elements you will subtract from A. Thus, another example A is A, B and C. So B, C, D, if you subtract from A, so that only one element you will get A. Symmetric difference, so A minus B union B minus A. So here in example, so A is 1, 2, 3 and B is 3, 4, 5. So A symmetric difference B is 1, 2, 4 and 5. In idempotent law, it is algebra. So idempotent law say that union of the same you can say that sets would be the same, right? A union A is A and A intersection is also A. Identity laws, so A union phi, that is again A. A intersection universal set would be A. Example, if A is 1, 2 and U is 1, 2, 3, so A union phi is also always phi, there is no element, so A union phi, that is 1, 2 and A intersection universal set, that would be 1, 2. Commutative laws, so A union B, that would be equal to B union A. In the same way A intersection B is equal to B intersection A. So union operator and intersection operators are commutative. Associative laws, A union B inside bracket union C is equal to A union B union C inside bracket, and you can see that this is also for a intersection. Example, you can put the values and you can check it. Distributive law, so A would be distributed over B intersection C. The same way for intersection. De Morgan's law are very important, and it says that if A union B complement is equal to A complement intersection B complement. The same way A intersection B complement is equal to A complement union B complement, and you can verify very easily. Now let us see application of sets, and some laws are very important that are useful for axiomatic probability and other modern probabilities. So number of A union B elements would be equal to number of A elements plus NB, means number of elements in B, minus N number of elements in A intersection B. The same expression you can write in this way: NA minus B plus N A intersection B plus N B minus A. Again N A minus B, you can write NA minus N A intersection B. Another, you can say that N B minus A, you can write NB minus N A intersection B. You can verify all the things using Venn diagrams. So I am leaving upon you, and you can also extend for 3 elements. So NA union B union C is equal to NA NB NC, and minus N A intersection B minus N A intersection C minus N B intersection C plus N A intersection B intersection C. And let us see an example. So in a group of 500 persons, 400 can speak Hindi and 150 can speak English. Find the number of persons who can speak both Hindi and English. The number of persons who can speak only Hindi, and third question is the number of persons who can speak only English. So you can see that those both can speak, that number is 500, and NA 400 and B is 150. So just you can put formula and you can find out NA intersection B, that is the number that person or people who speak both Hindi and English. The same way NA minus B, NA minus N A intersection B. So the number of persons who can speak only Hindi is 350. The same way using N B minus A, the number of persons who can speak only English is 100. So you can use this formula. So number of persons who can speak both Hindi and English is 50. Number of persons who can speak only Hindi 350. Number of persons who can speak only English 100. So hope you understood this concept, and these concepts we will use in axiomatic approach of probability and other concepts in probability. For other concepts in probability we will use. So hope you understood, and for more resources, videos like PDF and quizzes, simulators, you can visit website www.postnetwork.co. You can visit YouTube channel for videos and playlist. You can also visit Facebook page for a post and videos, and also you can connect to LinkedIn page of PostNetwork Academy. So hope you understood. Thanks for watching the video.